Okay, good afternoon. I am Dr. Jan Hichu, and this is a continuation on the SANS 10400XA lecture that we had earlier today, where we unpacked the standards. As you remember, we run through a number of the basic themes, the grounding of the standards, the three routes of compliance, and then we said, then we undertook and worked through the document following the prescriptive route. Now, like I've said in the lecture, and I repeat that, please do take the time to just briefly work through it yourself. So just take the document and check what the different segments are, and you'll quickly get a sense of the document and see that the prescriptive route's actually really easy. It's actually not as daunting as some might think it is, and that you can quite easily follow through. There's one aspect that we didn't discuss, and that was the question of fenestration. And how do you model or how do you define the performance of the fenestration with the new SANS 10400XA version 2? Yeah, so I'm not going to run through the whole presentation, but I will only focus on the fenestration part of it. I will quickly go to the notes though, and just start there, and then we will follow through with what happens in practice and how you actually undertake that. So you'll remember that there was a portion where we spoke about the articulation and form and how that defines the building envelope. And then we spoke about shading and the fact that you have to provide at least a minimum shading option that's compliant. And there are two options. The first being horizontal shading in terms of the extent thereof, and the second being a vertical shading that you can use, of which you actually need to showcase, if you use vertical shading, that you cover at least 80% of the glazing during the summer, astronomical summer period. Like I've noted, it's not necessarily that easy. It's very unclear in terms of how that gets assessed, and I assume you will do that with modeling in the process, and you'll have to showcase that you're actually covering a portion of it. Note that this can be, and just to highlight here, that this can actually be through manual, mechanical, electronic operated systems as well. So it can be a flexible system, but you need to showcase and provide documentation and design showing that you're actually using that as a method. You can also follow through with the horizontal shading device, which I would argue would typically work best north, northwest, and northeast. I don't agree with it being on the east and the western section because the sun is usually very low at that point. It doesn't actually make sense that you would do it, but this is part of the SANS 10400XA version 2 where they then define that. Now, just to remind you, and this is important why I'm going through this because this is important for the glazing thinking, that in the end you have to be able to consider what the extent of that shading device would be. Now remember, and I'm going to just take a pen, we're talking here of the horizontal shading device that extends beyond the edge of the glazing itself. Now, what do you consider there? You consider the lowest point of the glazing. You see that H up to the lowest point of the shading device, and that could be the roof eave like you see there, or a extent of the floor, or if you had a shading device right there at the bottom, then that would be the height that you would consider. And what we like to work out is what is that P? How do you calculate that P in the end? That dimension. Now, that is not a fixed dimension, but it's related to the latitude of that building or the site that you're working. So now I need to take you very briefly. I'll just quickly cancel here and we'll keep those changes. If you go to SANS Annexure C, you'll see in Annexure C there is a list of, oh, wow, and I haven't counted the towns, but there's basically any possible town in South Africa will give you the name of the town, the longitude, and then the latitudinal position. I'm trying to get to that latitudinal position there of Cape Town, there, 33.9. And then the energy region that we're working in, and then whether it's subject to the Southern Cape condensation problem. Now, that latitude is what's really important. So if you go to Pretoria, for instance, you go all the way down, and move a little bit quicker down here, and you will see that we are going down, down, down. And Pretoria, where are we? There we go. Okay, we see that we've got a latitude of 25.7. Okay, so that's important. Write it down somewhere, 25.7. If you then go back to the standards, and there's an excerpt here, so I'm just going to, you'll see in table 3 that you can then define the multiplier which you use to calculate the extent of that P, the extent of the shading device. And that's got to do with your latitudinal position. So you can see, okay, wait a minute, it's larger than 24 for certain, but it's smaller or less than 26. That we know, 25.7, which means we need to use the multiplier of 0.4. It was Cape Town, we'll have to go for larger than 32. You'll see you'll have to use a multiplier of 0.53. Believe me, that makes a difference. You can go and calculate that. And then what you do is you say basically that height, the extent of that height multiplied with that 0.4 gives you the extent of that, the length of the shading device that's needed. Also, on plan, how much it needs to extend on both sides of the window that you're providing. So what does it mean? The larger the window, the higher the height of the bottom line of the window to the underside of the shading device, the more the shading device need to extend. So the closer you bring the shading device and the shorter the window, the smaller the shading device needs to be. So that's the first rule. Remember, this is something you need to comply either way, but you'll be using that when you start moving to the glazing, defining the glazing for this project. So I'm just exiting here and scrolling down quickly to fenestration so we can get there. Okay, so we said fenestration, you need to consider the whole window, including both the window frame and the glazing. Everything gets included in the end, not only the glazing, which means the window could also be slightly larger. And then I said in the lecture that it's really important to understand that you're not looking at individual windows anymore, but you're considering it per floor, per story, per floor, and you're considering what I would call the solar exposed windows, which would be west, northwest, north, northeast, and east. Those are the windows that see a lot of sunlight, therefore get solar exposure, and the non-solar exposed windows, which is effectively the southwestern, south, and southeastern glazing. And what it means is you need to consider the mean or average or weighted average of the solar heat gain factor and the U value for the glazing that sees that gets solar exposure, and then also the weighted average for the U value for a window that does not get solar exposure. Now, ultimately, that needs to be that we get that average, and the one thing to remember is that on the south-facing windows, solar heat gain factor is not as important. Now, you'll get a window with certain solar heat gain factor properties either way, but you don't need to calculate. So if you go to the table, and we noted, I think that was table 8 in the document, and we can quickly have a look there. Fenestration. If we scroll down, table 4, apologies for that, that's table 4. You'll see in table 4 there's a few things you need to note now. Now remember, we said you need to consider the fenestration that gets solar exposure. You need to consider this fenestration that doesn't get solar exposure, and there we calculate either the solar heat gain factor, now it's the coefficient, the solar heat gain coefficient, reminder, you have learned about this before, is that it relates to the ability of the glazing to limit solar ingress. So the ability of the glazing to limit the amount of direct sunlight, direct short-wave radiation to enter the glazing. And you can see there's a difference if the glazing is compliant with the shading prerequisites in 5.2. We just spoke about that. Or if it's non-compliant, you can see that it needs to have a much better solar heat gain factor, and it's quite a difference. It's yeah. I mean, look at this. It's for glazing more than 35% of the net floor area, 0.49 versus 0.4. So that's the thing. So there's a differentiation between the solar exposed windows and those that are not exposed to solar. They all have to comply to very specific U values. That's important to note. So there it's across the board for all the glazing. Now, before you can do anything, you need to first figure out how much glazing is there versus the net floor area for each story. Now, how do you do that? And this is what we will consider. Okay. You'll see in the notes, I've given a short method, and that's the explanation in the method. So you can go through that again in detail. Now, I've given an example here. This is a very small 5 by 5 square meter building, and you'll see this is the southern side that's highlighted. There's a south facing window. There's a very large west facing window with, as you can see, no overhang there, so just a very large window. Let's not change it. And then there's a north facing window, much smaller, has some form of an overhang in the end, and then there are no windows on the eastern side. Okay, so 3 windows and a small building that on plan gives you the dimensions, the internal dimensions of 4.56 and 4.56 in that direction. Okay, so that's a typical building. Now, obviously, a more complex building, certainly more complex to understand. Now, what do you do? I've prepared a typical calculation for you, and this will be uploaded for you. But it's not the best model, so I mean you can develop your own Excel spreadsheet as you see fit. So typically you will give a building name for it, you'll note the town, and you'll note the latitude. Remember, we said that's important. Why is it important? If we know what the latitude is, then we can also define let's just get back to that, the multiplier that needs to be complied to. Okay, so once you've done that, you can put it into the table. So what you see here is we said if you're in Tshwane, it's 25 degrees. It's less or equal to 26, but still bigger than 24. And what you see here, if I define it, the multiplier here is not 0.36, but 0.4. An important factor to make. So put that in place. Make sure it's 0.4. And that is according to the multiplier that's defined by the SANS standard. So now that you've got an idea of what the shading multiplier is, because you need to know that in order to see whether you need to follow through with a shading compliant window or a non-compliant window. Next up, you need to first work out the floor area. So I just did a quick calculation here. You can actually go and measure it, but in this case we don't. But if you work out the net floor area, that's excluding all the external walls with anything, or all the internal walls included. So if there's a 110 wall inside, it will be included. I believe storerooms as well. But if you're interested, you can go and have a look again. Terms and definitions. You move down to net floor area. And there you go. Floor area within the building envelope, including area occupied by vertical elements such as internal walls, lift wells, enclosed staircases, storage rooms, areas, and rooms. So the way I interpret it is that it is what is inside that building envelope. So the external walls are excluded, but the rest all needs to be included. And so my calculation, 4.56 gives me a square meterage of 20.7. That gives me the total floor area. Now, why do I need to understand that? If you go back to that table number, Fenestration, table number 4, you'll see that you need to define the performance of the glazing based on the amount of fenestration per net floor area. So you basically need to get this fenestration to net floor area ratio. That's important. So you've calculated the total floor area, or you've measured it, and in Revit you would possibly do that. And then you've got your windows. So you go and you quickly check what's the total size of your windows. I know you guys can model it very good and generate tables quite quickly in Revit. So you can very quickly get a sense of the total amount of glazing. So I did a quick calculation. You don't need to do calculation. I'm sure you can. There's better shortcuts. But it's the length times the height for each window. I get the floor area. There's only one window of each, so it's actually quite easy to calculate. If there are more, you'll obviously have to change that. You get the total area for the solar facing windows and the non-solar facing windows, 3 square meters. That gives me 12 square meters, and I would then have to go and calculate that. So 12 divided by the total floor area gives me a window to fenestration ratio of 60%. Okay, we know. I mean, that's, if you look at the model again, that is not a surprise. I mean, if you look at that single room, okay, let me just right. If you look at the single room, there are certainly a lot of glazing in here. So what happens now? Now that I've defined how much glazing it gets, okay, so we've got to go back. We see we've got 60.1. I think you can possibly get away with saying 60%. You'll see that 60% basically starts defining what the type of glazing is I need to use. I already need to just simply use that. So I see there, because I'm using 60% of glazing, all my glazing needs to have a U value of 2.2. That is a non-negotiable. So go back to my table, and I'll say this window, and it's just simply good. It's good to define the windows separately. You'll see the U values for those windows are 2.2, 2.2 right through, and all my southern glazing will also be 2.2. So that, I think, is actually quite straightforward for U values. You can work out the mean. It's not the mean, but the mean would be similar. So how do you work out the mean? You could go and say 2.2 times the total glazing area. Typically, again, 2.2 times 2 gives you the total in the end. That total plus divided by the total floor area should give you the mean U value. But now remember, when you look at this table, clearly there's no differentiation between the U value, so it's fine. It's 2.2. That's what you need to use. It's a very good performing glass that you've got to use throughout the building. Now, the differentiation comes actually in when you start dealing with the solar heat gain factor. And the reason being is, you'll see there that if you've got 60% of glazing, you need to differentiate between a 0.3 solar heat gain coefficient if you are complying with shading, or a 0.25 if you're not complying to solar glazing. So you now need to go and see whether you comply or not. Remember, non-solar facing glazing that doesn't get exposed to sunlight, gets any solution. So again, you'll just use the worst performing. You'll probably use 0.3 would be my advice. But you can probably even have glazing there with very good U values and very low solar heat gain coefficients, and it should be fine. Now, let's go back. We now need to do a quick calculation. We've got the floor area that we've had to calculate. That's important. We also note how many windows, so you get the total floor area, because remember, we want to calculate the mean solar heat gain coefficient. So now, what we need to check now is, do the shading actually comply? Now, typically you can do that for every window, and you don't need to measure it, model it, or put it in Excel. You can simply go and say, okay, let's take this glazing. I've got a west facing. Let's go and measure the size of the glazing, but let's go and measure the height of the underside of the glazing to the very top. And if we go to the north side, do we see any shading device? No, there's none. So I think it's actually quite simple. But it is sometimes, if you've got lots of glass you've got to deal with, it might be easier to develop an Excel spreadsheet, because in the spreadsheet you can constantly check whether you're complying with that multiplier in the end. Do you actually, is it correct? So first window number 1 is the west facing window. I would define it better here. I would say west, or I'll give it a window number. I think that's even better. And we go to that window number, we get the basic size like we've done already, and we note that height 2890. So you go back to your table, you note here the height is 2.890. Actually, this shading device is 0, so we know that. But to be compliant, you need to take that height times 4, and it needs to extend for 1.15 meters. I mean, that's a very quite a broad shading device. But needless to say, we know it's non-compliant. So if it's non-compliant, let's go back to our table and we see 60% non-compliant glazing gives us 0.25. We go back to that table and we type in 0.25. That's the shading coefficient we must have. Now, how do we'll get to calculate the mean now for you, because that's important. Okay, so that's the thing. We now know that's the type of shading coefficient that we do need for that glazing. Now, the second window, the window on the northern side, we know is a slightly better design. So you can see it's 800. It's quite a narrow, horizontal thin window, but up to the shading device is 1450 or 1.45 meters. Okay, that's the first thing you'd like to note. I'll show you on the west. You can actually measure it there if you, there's obviously ways to make sure that you get that dimension in the end. Either way, so there we go. We've got that height. So we go and type that in. 1.450, or you can work in millimeters throughout, just work with 1 unit throughout. Then we go and say, well, what's the actual chain device length that we've designed? And if you go to the west view, we see, okay, from the window, and actually I would even draw a section through there, because you might even gain a little bit. If the window's in the middle of the wall, then we might actually have 600 plus 110. So it's about 700 mils if you really want to be accurate there. But either way, so let's say it's 600 mils, the extent of the shading device. Then you put in your actual. We know that's 0.65. And because you've put the multiplier in, it automatically calculates for you what it should be if you comply. 1.45 times 0.4 and gives you 0.58, which means I'm complying with the shading device. Now that allows me to use a 0.3 shading coefficient for the window. Now what happens? I put that in. I could then go and calculate the mean solar heat gain coefficient I need to use, which means I take the total area of the windows times the compliant shading coefficient that I need to, solar heat gain coefficient that I need to used. And I do the same for the other window. Total area times solar heat gain coefficient. I add those two together as a total. I divide that by the total area of the glazing, and it gives me a total coefficient of 0.26. Doesn't make a huge difference. But where it would make a difference is if I, for instance, have, let's say I have got a very long northern facade, and let's say there's about 10 of those windows that has a much lower, a much lower solar heat gain coefficient that needs to be used. And I then calculate the total area now. I need to adjust that, which would be the total area times that. And immediately, that should give me a solar heat gain factor, which should be, yeah, that's a good question. Why am I struggling now? Because I should be able to get a solar heat gain factor that is correct. Let me just quickly see what happens here. Oh, yeah, no, quite obviously that is, I've got a problem here. The total area. I added that to 10, so I need to adjust that. That's 20, so that should be correct. But I now need to add a few more of these. It's not 9.5 anymore, it's actually 9.5 plus additional 8, so the total is 17.5. And you'll see immediately I can actually, I should be able to get, no, it's not 8, it's 16. Okay, apologies there. Okay, so what I'm trying to show you here is, if you have, the reason why we use the mean solar heat gain coefficient, if you have the single window, it doesn't actually make a difference. But once you've got a poor performing window and maybe lots of better performing windows, that actually gets accounted for in that model. And you can see in this case that it ultimately means you can actually, if you've got lots of shading compliant windows and one really poor window, it still allows you to ultimately use a lower solar heat gain coefficient, which is what you want to try and get to. So that's the thinking behind the mean solar heat gain factor. So it doesn't calculate that for every single window in the end. In the end, it says, okay, I now know that you've designed this building, but I'm going to take the mean, the average, for all your north, northeast, east, west, northwest windows and calculate that. And similarly, you'll take your non-solar facing windows, the south, southeast, and southwestern windows, which in many cases I think will actually lead to slightly lower performance needs than you would need to get. You can see here, if I'm looking at the southern facing window, again, I just calculate the size, the total number, it gives me the total area. In this case, I do not need to consider the shading, whether it's shading compliant or not. So I can just use the U value as defined, and ultimately I will just define it as such. Let me just fix this again, because I think we are going to struggle if we if everything's incorrect. So just to recap again, when you're calculating or thinking about the fenestration, how do you comply? Remember that you need to, I'm going to go to those steps again. I think that's easier, then you'll know what to look for afterwards. Where are we? There, okay. Remember that you need to calculate the solar facing windows and the non-solar facing windows. first of all. Then you want to only calculate the mean value of the U value, but the U value, just a reminder, is dependent on all the glazing. So you take all the glazing and you divide it by the floor area, and it gives you that ratio that you'd like to use. And all the U value throughout the building is defined by that. And then in order to understand the solar heat gain coefficient, you have to separate the two windows up. And those that are exposed to solar, or the solar windows, and those that are not exposed to solar, the non-solar windows. And then you have to check for the non-solar exposed windows, the south-facing windows. You do not need to bother. You can just define any solar heat gain coefficient for those windows. But if they are north and they're solar facing windows, so they get sunlight, then you ultimately need to check how many of them actually comply in terms of the shading and how many of them don't. And then you work out the mean, average, and end. And like I said, I mean, I quickly put up this table. I don't think it's perfect. I think it needs a lot of work still, but I want you to actually develop it yourself. So it's more important to understand what's happening than having a little table or tool that you can fill in and you don't need to think about it. It actually is a very simple process. It simply requires that you think about your glazing in terms of its overall amount of the used in the building, and then which are solar compliant, shading compliant, and which are not. Yeah, this brings me to the end of this video. I hope that this helped you, and if you're welcome to contact me if you have any questions. And yeah, I'll see you next week in class again. Thanks.